A solar cell or photovoltaic cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect, which is a physical and chemical phenomenon with electrical characteristics such as current, voltage, or resistance vary when exposed to light. An array of solar cells converts solar energy into a usable amount of. A photovoltaic cell is composed of two different types of semiconductors, a p-type and an n-type, that are joined together to create a p-n junction. By joining these two types, an electric field is formed in the region of the junction. Light enters through an optical coating or anti-reflection layer that minimizes the loss of light by reflection.
Working process. 1. When sunlight shines on the cell, photons, meaning light particles composed of electromagnetic energy, bombard the upper end layer. 2. The photons carry their energy down through the cell. 3. The photons give up their energy to electrons in the lower p-type layer, escaping its bond with the atom, leaving a hole. 4. The electrons use this energy to jump across the barrier into the upper n-type layer and escape out into the circuit. 5. Then, the generated electric field by the p-n junction causes negatively charged particles to move in one direction and positively charged particles in the other direction. Electrons and holes move in the opposite direction as expected. So, by this, electrons move to the positive p side and holes move to the negative n side. By flowing in opposite directions, an electric current is produced.
Solar cells transfer energy from the photons in sunlight to the electrons in the solar cell. The more photons of sunlight absorbed by the solar cell, the greater the electric current. The maximum voltage, on the other hand, is fixed by the material the solar cell is made of. Electric power is the product of the voltage across a device and the current through that device. Engineers use the theoretical power to characterize a solar cell. The power provided by the sun per unit area, known as solar intensity, is approximately 1000 watts per meter squared. As the power of a solar cell depends on the voltage and current generated by its cells individually, voltage in a solar cell will be between 0.5 and 0.6 volts, and they will produce a current between 28 and 35 milliamps per square centimeters. Photovoltaic phenomenon is one of the most efficient renewable energies nowadays. Thus, the majority of the times are used for big electric power devices such as in the industry, households, or hotels. Regarding the application of these devices, the existence of solar panels doesn't end in the non-silicon ones, which are the ones we know. Other cell types have been developed that compete either in terms of reduced cost of production, solar cells based on the use of multicrystalline C or Si ribbon, and the thin film cells based on the use of amorphous C, CDTE, or CIGS. Or in the terms of improved efficiencies, solar cells based on the use of 3B compounds.
To conclude this investigation, it is useful to know how the photovoltaic effect helps reduce the cost of energy in any household or industry, as well as the reduction of contamination that contributes to climate change in the world. The photovoltaic effect is a very important part of renewable energy, which is recovered from the sun and can be used through solar PV or solar thermal. It is, as also mentioned, a great help with energy bills, since you do not pay the energy produced by the solar panels. The use of solar cells is more than trustworthy, since this renewable energy will never be drained because it is recovered from the sun rays. Also, it is important to mention that solar energy has been one of the latest discoveries regarding renewable energies. Thus, it's an innovative business under continuous research and development.